Hello everybody and welcome to a new video. In this video we will be talking about Coulomb's law. So in the previous lesson we learned that charges either attract or repel to each other depending on their type. So we know that similar charges they will repel and different charges will attract. But we never understood or we never talked about how strong do they pull each other. So do all charges pull each other in the same strength? Well, actually that's what the scientist Coulomb discovered. So Coulomb stated that the force between two charged particles depends on two things. It depends on the amount of the charge, and it also depends on the distance between the charges. So there are two factors. The first one is the amount of the charge, and the second one is the distance between the charges. Okay, so what is this relationship? It's very easy. We can say that the electrical force between these two objects depends on Coulomb's constant. This is something called Coulomb's constant we will be learning about in a bit. And Q1 is the charge of the first particle, Q2 is the charge of the second particle, and R is the distance between these particles as written down here. The force between charges, it's in newtons. It's very important to keep that in mind. And Coulomb's constant is 9 multiplied by 10 to the power 9. R is the distance between these particles, and its unit must be in meters. Okay, so R is the distance between these particles and the unit is in meters. Well, before we go to solving some problems, actually we finished what we want to know about Coulomb's law, so we will start solving some problems. But in order to do that, we must do a little bit of freshing to our memory about the relationship between the powers. So if I have x to the power n and the whole thing is to the power m, we will have x to the power n multiplied by m. So we'll multiply n by m and it will become the new power. Okay, if we have x to the power n multiplied by x to the power m, we will have x to the power n plus m. Look at the difference here. Here we multiply them together. Here we added them together because here x to the power n was multiplied by x to the power m. But here x to the power n, all of it was to the power m. Okay, and finally x to the power n divided by x to the power m will be equal to the x to the power n minus m. So we will subtract n minus m and we will have x to the power n minus m. So it's pretty easy. Let's start solving some problems. Something else we must also keep in mind, the negative sign is not important when we are solving problems in Coulomb's law. So it's pretty straightforward. So let's start with some problems. Try using Coulomb's law to find the electrical force for the following cases. So we have the charge of the first particle, which is 9 microcoulombs. Remember, we said we will be using microcoulombs a lot. And we have on the other side, we have a negative charge that is negative 5 microcoulombs. And the distance between these charges is 0.05 meters. Okay, it's important to think of this as the following. This is not a proton and this is not an electron. This is not a proton and this is not an electron. These are charged particles. They contain many electrons, or they must have lost a lot of electrons. Okay, so this is not an electron, this is not a proton, these are charged particles. Okay, so the relationship is easy. The electrical force is equal to Coulomb's constant multiplied by Q1 multiplied by Q2 divided by the distance squared. So we know that Coulomb's constant is equal to 9 multiplied by 10 to the power 9. Then we multiply it by the first charge, which is equal to 9 microcoulombs, which is 10 to the power negative 6. Then we multiply it by 5 microcoulombs, which is 10 to the power also negative 6. And it's important that we forgot about the negative sign. We will not use it in Coulomb's law. There's no need for this negative sign. Divided by r squared. R is in meters. We must check that it's in meters. So the distance is 0.05. All of it will be squared. This will give us a final answer of, using our calculators, we will get the answer is equal to 162 newtons. And let's not forget about this sign. Let's solve another one. It's pretty straightforward, but we need to keep an eye on some of the tricks. Like here, the distance this time it's in centimeters, and it's very important not to forget to transform it into meters. So 10 centimeters, if we want it in meters, it will be equal to 10 multiplied by 10 to the power negative 2, or it's just simply 0.01 meters. Now, we will finish this problem by doing the following. We know that the force F is equal to Coulomb's constant multiplied by Q1 multiplied by Q2 divided by R squared. So the trick here is to keep an eye on the unit. It's in centimeters, but we need it in meters. So it will be 9 multiplied by 10 to the power 9 multiplied by Q1, which is equal to 9 microcoulombs. 9 multiplied by 10 to the power negative 6 multiplied by the second charge is 7, so it's 7 multiplied by the power negative 6 divided by the distance, which is equal to 0.1, sorry, 0. Yeah, it's 0.1, not 0.01, 0.1 squared. And we can use our calculators to find this problem. And the final one, it's actually just like the one before it. You just have to concentrate on the unit, so it's straightforward. The F, electrical force, will be equal to Coulomb's constant 9 multiplied by 10 to the power 9 multiplied by 9 10 to the power negative 6 because it's microcoulomb multiplied by 3 multiplied by 10 to the power negative 6, and all of this will be divided by the distance. The distance is 0.12 meters. We transformed it into meters, so it will be 0.12. All of it is squared. And using our calculators, we will get the final answer, and we'll not forget about the unit. It's in newtons. Okay, what are other types of tricks that we can see in Coulomb's law? Actually, it's very straightforward. We just need to know the formula, and we will plug in the numbers and we will get an answer. Well, actually, sometimes we can ask about the effect of multiple charges on one charge. How is that? Let's say we have more than just 2 charges. We have 3 charges. What is the final force between these charges? That's what we will be seeing in the next video, so stay tuned.